Welcome, everyone. Thank you for joining us today. Our topic is optimizing GenAI systems with Snorkel and AWS. So we have quite a bit to cover today, but a little bit of housekeeping for everybody. Along the right side, you should see icons for chat, Q&A, and resources. Please feel free to use the chat. If either you just want to share some thoughts with everyone, or you're having some questions or technical issues with the webinar platform, we'll be keeping an eye on that. Please do ask questions throughout the webinar using Q&A, and the team here is going to do our best to get to as many of those questions at the end. We'll try to save 5, maybe 10 minutes for Q&A. And then the presentation is itself available in the resources tab to download. Along the bottom, I think I saw it a minute ago here, there are some emoji. You're welcome to click on those throughout. If something is relevant or exciting, you can share that. It will float above the screen for everybody, kind of thing. In terms of the agenda, we're going to start off. We're very fortunate to have a guest joining us from AWS, who I'll introduce in just a moment. She's going to help us better understand AWS Bedrock, SageMaker, and some other AI services available. I am then going to give a very brief overview of Snorkel Flow for those of you who may be new. Then I'll spend a little bit of time on kind of inner workings of RAG optimization. And finally, one of our great machine learning engineers, Vignesh, who we'll hear from in a little while, he is going to do a fantastic demo using Snorkel Flow and AWS to do some RAG optimization and provide us with some additional insights there. So quick thing here. Myself, I'm Shane Johnson. I'm responsible for product marketing here at Snorkel. As I noted, we're very, very fortunate to have Sindhura joining us here, although I think I might have a typo in there. I apologize. But with that said, I am going to pull my slides. I'm going to turn it over to Sindhura and let her take it away.
Sure. Just a second, please. Yep. All right. So thank you, Shane, for the introduction. And first of all, good morning, everybody. Thanks for joining this webinar. I hope you'll find it interesting and learn something out of it. So I'm a senior solutions architect from Amazon Web Services, and today I'm here to talk to you about Amazon Bedrock and SageMaker some start, because we'll be leveraging these services for the upcoming demo. And in the interest of time, I'm just going to provide a brief introduction of the core functionality that these services offer and also go over some of the new announcements. So, I am based out of San Francisco Bay Area, and I've been with AWS since a little over 5 years. All right. I'm super excited to see how today's session goes, and you'll be able to see how the partnership between Snorkel and AWS can help optimize the generative AI systems. With no further delay, let's get started. So, Amazon Bedrock is, first of all, a fully managed service that makes it easy for you to get started with building up of your own generative AI applications. Bedrock offers a choice of high performing leading foundation models. We'll go through the list of foundation models in the next slide, along with a broad set of capabilities for simplifying the development for your generative AI applications. So you can now easily experiment with the variety of top foundation models, customizing them privately with your own data using techniques such as fine tuning or continued pre training. You can also leverage the retrieval augmented generation with the help of Bedrock knowledge bases by connecting with your company's private data resources. And you can also play around with the Bedrock managed agents that can help execute the complicated business tasks, from booking travel, processing insurance claims, to creating ad campaigns, or even managing inventory, all without writing much code. And since Amazon Bedrock is serverless, you do not have to manage your own infrastructure. That's the best part. And it securely integrates with several AWS services that you may be already familiar with and you may be using. Since Bedrock is such an important service, just like any other AWS service, we have always emphasized on the security and privacy right from the day one. And Amazon Bedrock offers several capabilities to support your own security and privacy requirements, and is compatible with common programs such as GDPR, HIPAA. So, as you see here, these are the list of we have a broad choice of models here. And one thing that's important is, as everybody's already familiar with, customers are moving fast. And at the same time, generative AI is also evolving rapidly with new options, innovations happening practically on a daily basis. And at the times that we are currently in, so the ability to adapt is the most valuable tool of all. So at the end of the day, what does everybody need? We all need capability to experiment, deploy, iterate, and pivot quickly. And we want to be able to do that with the latest and the most recent foundation model. So today, Bedrock provides access to a wide range of foundation models from different leaders that you see here: AI 21 Labs, Anthropic, Cohere, Meta, and we have our own Nova models. And also, there's a new capability in Bedrock. It's known as Amazon Bedrock Marketplace that enables developers like yourselves to discover, test, and use over 100 popular specialized foundation models alongside the models that we have already listed here. So I would not like to talk briefly about the Anthropic Claude models on Bedrock because we are going to leverage them in our demo today. So what's really exciting about Anthropic is the range of AI models that they offer to fit different kinds of use cases, allowing you to choose the most cost-effective solution for your specific needs. So Claude models are very flexible. So you can start with either simple tasks, there's a model, and you can scale up to do the most complicated tasks, all without changing the provider. And as your AI needs become more and more sophisticated, you can, once you start experimenting with the smaller models or simpler models, you can seamlessly upgrade to a more powerful model without a major re-architecting or re-engineering of your systems. And all Claude models maintain Anthropic's high standards for accuracy and reliability, providing a safer foundation to start your generative AI application building with. So these are the different Claude models available on Bedrock. So today's Anthropic's most advanced model is Claude 3.5 Sonnet. This shows it's a beautiful balance between the intelligence and the cost as well as the speed. And also we have a Claude 3.5 Haiku model. If you would like to quickly get started with the fastest and the most affordable model, then Claude 3.5 Haiku is the way to go. We also have Claude 3 Opus, and Claude 3.5 Opus will be coming out this year. But Claude 3 Opus is also a very intelligent model that can be used for solving the most complicated problems, which include reasoning, mathematics. So it's a very powerful model. And you can play with all these models using the Amazon Bedrock Playground functionality. So apart from the cloud models or any other models, so we also have Amazon Nova Foundation models, which have been recently announced, and this is a new family of state-of-art foundation models available exclusively on Amazon Bedrock. And these models are designed to deliver advanced intelligence and cost-effective performance across various tasks. So as you see, there are two types of Nova models. One is like understanding models, and the other is the creative content category. And the understanding models contain like micro, light, pro, that process text, image, video inputs to generate text outputs. And then we have this creative content generation models like canvas and reel for producing images and videos. And the fourth understanding model, which is the Nova Premium model, is set to be released in 2025. It is going to come out soon, and which offers advanced capabilities for complicated reasoning tasks. So now that we have spoken about models that are available, so if you want to import your own models, like for some of your use cases, you have some models that you already fine tune and you want to use those models. So Amazon Bedrock provides you the capability in order to import those models into Bedrock and access them on demand, and also without the need for you to manage any of the underlying infrastructure. So you can accelerate your own generative AI application development by using your own custom models with native Bedrock tools and features that are available, like knowledge bases, guardrails, agents. And the custom model import is currently support fit for architectures like Llama, Mistral, Flan. So now we have spoken about the models, but it's the support for retrieval augmented generation is also very important, and that's, I think, it's one of the widely used mechanism in order to improve the accuracy of the models. So it's like to equip the foundation models with your up to date proprietary information. Organizations generally use retrieval augmented generation, a technique that involves fetching data from your company's data resources and enriching the prompt to deliver more relevant and accurate responses. So, knowledge bases for Amazon Bedrock is a fully managed RAG capability, and it automates the end-to-end RAG workflow, including like ingestion, retrieval, prompt augmentation, eliminating the need for you to write your own custom code in order to integrate different data sources and to manage these queries. So these are the different options that are available, like for you to build your own RAG based application. So you have your natively available Bedrock knowledge bases, like Amazon OpenSearch Serverless, where you can provision through that through the Bedrock knowledge bases, or you can use Pinecone, Redis, Mongo, and you also can work along with Amazon databases like the Aurora PostgreSQL and DynamoDB. Several different kinds of options are available for you for the RAG. So, other than RAG, the other way to customize models is through fine tuning or continued pre training. So, you must all be already aware that when you build AI applications, it's important for your AI applications to know what's relevant to your customers, what's relevant to your product, what's relevant to your business. And that's only possible if you supercharge your models with your data. And when you want to build generative AI applications that are unique to the business needs, the data is the differentiator. Data is the key from moving from generic applications to generative AI applications that create actual value to your customers and to your business. And Snorkel plays an immensely important role there. So, how do you go about customizing these models with your own data? So, the options available are fine tuning and continuous pre training. So, fine tuning is a common technique that is used to customize those foundation models. But with fine tuning, you provide your own label data sets, which are annotated with additional context to train the model on specific tasks. So, you can adapt the model parameters for specific tasks based on the business context. And Similarly, if you want to go ahead with continued pre-training, you can leverage your unlabeled data sets or raw data in order to maintain the accuracy of the foundation model for the domain. So, for example, if a healthcare company is there, they can continue to pre-train their models using the medical journals or articles, research papers to make it more knowledgeable on the industry terminology. So it's I'm excited to say that Bedrock is the only fully managed service that provides customers with the ability to fine tune cloud models, and you can go ahead with fine tuning Anthropic Claude 3 Haiku models in Amazon Bedrock. Makes it very easy for you to do so. So the next most popular topic is Bedrock agents. And agents are all over the place. Everybody's talking about it. What makes agents so cool is that agents are able to leverage the reasoning capabilities of, the foundation models. They're able to break down complicated tasks and orchestrate them, and efficiently completing them. Thereby freeing up several different resources that can actually be used to do some other complicated tasks, right? So agents are able to also securely connect to your company's data sources and augment the user requests with the right information to generate accurate responses. And they can also automatically call the required APIs to transact with your own company's systems, the processes, and take their decisions, determining whether to proceed, whether or they have to gather more information in order to proceed. So agents for Bedrock also come along with enhanced capabilities like that you can use to improve the control of orchestration, or you can also get better visibility into the chain of thought reasoning that goes behind the agents. And it's interesting to see that for more advanced needs, Amazon Bedrock also supports this multi-agent collaboration, allowing multiple specialized agents to work together on complicated business challenges. So in a model where there's a supervisor agent and then there's the sub agents, they all work together, communicate together to achieve whatever you desire. So apart from the agents, there's another important underpopular mechanism in order to make the models more cost effective is the model distillation. So recently we introduced Amazon Bedrock model distillation, which allows you to utilize smaller cost effective models for your use cases. So distilled models in Bedrock are way faster and are 75% less expensive than the original models. So, what will happen, just to tell it very briefly, is with model distillation, you can choose a teacher model, which is the accuracy that you actually want for your use case. And then you can select a student model that you want to fine tune. So, model distillation automates the process of generating the responses from the teacher model and then using those responses automatically to fine tune the student model. So through this, you can actually make the model like an expert in that specific field, and it's also very cost effective because it's a smaller model. And in addition to the other cost optimization measures, so this is also very important announcements that we recently made, was the intelligent prompt routing, which enables you to route your prompts to the right foundation models to reduce costs further. Like for example, with Anthropic Claude model, your Bedrock can intelligently route requests between 3.5 Sonnet or Cloud 3 Haiku, depending on the complexity of prompt. And then we also have this caching support, which allows you to cache repetitive context in prompts across multiple API calls, which can reduce costs up to 90% and even the latency by 85%. So these two are very important mechanisms that you can leverage to reduce costs. And finally, I just wanted to talk briefly about the inference consumption options that we currently offer, which is on demand, which is like pay as you go. And if you want to like quickly play around with things, you can definitely leverage this option. And if you want to quickly experiment as well. But if you are at a production stage and you feel like you need more options which are like kind of which can help you reserve the throughput, right? So that's when you can use provision throughput, and where you can provision sufficient capacity in order to meet your application's performance requirements. So definitely find out more, read up more about provision throughput when you're at that level, when you have finished experimenting, when you want to go production. That's when you can at least try understanding what this is. And also finally the batch inference, where you can use Amazon Bedrock to process prompts in batches to get responses for model evaluation, experimentation, and offline processing. So, batch inference allows you to process in batch and at discounted rates. So, if you want to do some batch inference, definitely instead of using on demand, you can refer to the batch inference consumption model. All right, so this is all about Bedrock, and I just would like to take one more minute to go over SageMaker Jumpstart as well, since this is also another service that we'll be going to showcase in the demo. And with SageMaker Jumpstart, it's like if you want to have more control over the infrastructure, right? If you want to determine or change the model training and deployment methodologies, if you want more control there, so this is the service that you can use. And it is a machine learning hub where you can actually browse from a collection of more than 250 foundation models. You can evaluate the models of your choice, customize them, deploy them yourselves, and manage the infrastructure as well. You can choose the instance type that you want to provision. So there's so many things that you can do through SageMaker Jumpstart. And sorry, I think I went ahead. So here also you can find a numerous amount of proprietary and public available foundation models from different model providers, and to perform a wide range of tasks such as article summarization, text, image, video generation. And you can also further customize these particular models. This time you'll have more knobs and dials to do whatever you want. Right, you can use advanced fine tuning techniques like domain adaptation, instruction fine tuning. You can bring in your own data to fine tune. You can use the example data that's provided. You can also modify those 20 plus hyperparameter option in order to customize the use case according to your own needs. And finally, even for deployment, it's like you have one-click deployment options, as well as you can also customize the deployment configuration, ranging from the instance types that you want to select. And you can deploy multiple copies of the model to a single instance. You can deploy it within VPC. You can also enable auto scaling options for scalability. So I hope I was able to provide you some context around these two services, and I would like to hand it over to Shane. Thank you for your time.
Thank you, Sindura. That was fantastic. I appreciate it. Let me pull up my slides here for everyone. We'll try to move fairly quickly. I want to make sure we save time for our demo and Q&A. All right. Hopefully everyone can see my slides, and I'm going to go ahead and get started. So catch up here a little bit. Snorkel Flow. I'm going to be very brief here for those of you who might be joining us for the first time and not too familiar with it. But the core philosophy here is that the key to unlocking enterprise AI production applications is AI data, and the key to curating that AI data is sourcing it from enterprise data and SME domain knowledge. Right? These two areas are where we have so much valuable information. If we can find a way to capture that and bring that into our AI model, we can solve domain specific tasks with much greater accuracy. So in a nutshell, kind of behind Snorkel Flow, two key points is pragmatic data development, which allows you to scale a lot of these operations, and then human in the workflows, because we recognize how important it is for AI teams to be able to collaborate efficiently with SMEs. And we generally have two, higher level workflows, one for GenAI, one for predictive. But both of these workflows, while they have different mechanics, the idea is still the same, right? Which is being able to take advantage of SMEs and repositories of enterprise data and transform that into AI data, and or build machine learning models. Essentially, if you look at the bottom, this is kind of the core belief, right? How can we transform this information into AI data? And then on the upper half of that middle box is kind of how we approach this, right? We have automation, which is backed by those programmatic data development operations I referred to, as well as interfaces for facilitating human in the loop collaboration. And all of that is done via a combination of UIs, SDKs, and workflows. Right? This helps AI teams effectively and efficiently collaborate with SMEs to essentially take that initial AI prototype, which probably doesn't really meet the accuracy requirements you're looking for, infuse that domain knowledge through AI data to something that you can deploy into production reliably. We kind of look at the workflow a little bit like this, right? Evaluation is really the starting point. You kind of need that to help you understand what is the quality or the state of a prototype, for example, that you're building. Depending on those results, we can try to prompt engineer away any issues, get some improvements to there. If that's not enough, right, we go back, evaluate, we do some RAG optimization, go back and evaluate, and if need be, when you graduate, kind of the upper level here, you'd be fine tuning your LLMs is kind of the last stop there. And then even still, right, we go back for continued evaluation to ensure that our AI application is responding the way we expect it to, even as the number of users and use cases continue to expand. That being said, I'm going to focus a little bit here on RAG optimization in particular, and also kind of give you a heads up. I'm going to move fairly quickly to these slides. I might even skip a few in the interest of time, but the deck is available to you. And if I'm moving quickly, like I said, please feel free to ask questions throughout. What I have here, kind of a little bit of a busy diagram of a RAG pipeline, kind of flushed out a little bit. There's probably a few more details that I might have liked to add, but it would just made it a little bit harder to read. So this is kind of the state of things, some of the major components. And then here are the areas where we can do some improvements. So in particular, the dark blue spots, those are areas that we can use to improve our RAG pipeline. The light blue ones, those are areas for improvement too, but I'm not going to be able to cover those today. Finding tuning LLMs is an entirely separate webinar, which we've done before and we'll certainly do again. And I think re-ranker models, while helpful, are really still secondary to improving the embedding model first. So I want to recognize those, but we're not going to really dive into them. And then the other thing I wanted to highlight, which is great to have Sindhur here and walk us through Bedrock and SageMaker, is that in fact we can use foundation models to help us in a number of these stages, right, and improve a number of these components, which I'll explain here in just a minute. So I'll start with chunking. And within RAG pipelines, chunks, if you're not terribly familiar with it, the idea is we start with a document, it could be very large, and we want to split that document into smaller pieces. And those small pieces we refer to as chunks. Those chunks are ultimately passed to the LLM as context to provide it what is otherwise not public information, right? It needs additional information to answer a question. The challenge here is that if your chunks are too big, then they get noisy, right? They're pulling in irrelevant context that can distract the LLM. If they're too small, then they're missing some of that relevant context, which is going to be needed. And so there's a little bit of care involved in ensuring that the chunks are logical and, I would say have no more and no less than what's needed to answer a question. In terms of those strategies, fixed is what you probably see the most often, right? People getting started out of the box, we set a token count of 500, right? And we set an overlap of 100. So, these chunks are basically 500 tokens. It doesn't matter where it's split in the middle of a sentence or a paragraph. I would definitely suggest, don't continue with that approach. You really want to think about it more naturally, right? If I were a person and I wanted to split a document, how would I do it? Probably by section, right? If I see a paragraph followed by a table, I probably want to keep those together, if they reference each other. And that really kind of comes into Snorkel's approach. So we have our own method of chunking, and we try to follow the natural structure of the documents, looking at their headings, parsing tables appropriately. And this alone can give you a fairly significant bump in retrieval accuracy, right? Just by switching from naive chunking to a smarter approach. The next piece is metadata extraction, which I would say is one that a lot of folks probably don't think about, and you probably haven't seen in similar diagrams before, but we found to be extremely valuable. And the idea is that you might have a chunk of text, but there's value if we can extract metadata about that text. Does it cover, a certain topic? Does it have certain data in it? For example, if we were looking at healthcare plans, maybe there is a chunk and we want to add metadata that, hey, this talks about deductibles, or this talks about payments or co-pays, or this chunk has examples of payments due based on your combination of deductible, copay, et cetera. We do that for two reasons. One is that it can help us filter out the chunks that are needed for fine-tuning our embedding model. Because if we've done evaluation, which I mentioned at the beginning, we might know that our co-pilot or assistant is struggling with certain types of questions. And so if we can tag these chunks, we can identify the ones that can directly help fix that error. The second reason is those chunks can actually be used to improve retrieval directly. So most of the time, the query is passed to an embedding model. You then take that resulting embedding, you pass it to a vector database. It does a similarity search based on those embeddings and gives you the results. There are two other alternatives. One is you could simply specify the keywords and say, regardless of the embedding, just find me the chunks that cover deductibles. Or two, you can send both the embedding and the keywords. So find all chunks that are relevant to this question and are tagged with this keyword deductible. So there's a lot of value in adding metadata to our chunks and not just dumping them into a vector database directly. How we go about it, Within Snorkel Flow, we have this notion of information extractors and classification models. And we can use a combination of those to extract and apply metadata to our chunks. And here's just a little example. This is actually from a health plan. The idea is, we could look at subsets of here, right? That blue text might be a chunk. And so we could look at the title and we could determine, okay, we should tag this notification of change, right? In case anyone asks questions about how to change their health plan or when they can change their health plan. We might want to tease out things like dates, regardless of the date, whether it's a start date, an effective date, a payment date. For example, we worked with a customer once where their co-pilot struggled with questions around dates. And so we went and chunked their documents. We found the ones that reference dates and tagged them, and then filtered those out to use as training data so that the embedding model was better at finding chunks that could answer date related questions. Synthetic data and the embedding model. I'm kind of pair these two together here. Usually when getting started, I'd say it's not very often, maybe not at all, that someone has a full training data set available for fine tuning and embedding model out of the box, right? Chances are you're going to have to create one from scratch. But before I get into that, why is this important? Embedding models are responsible for, helping you identify chunks that are relevant to questions, right? They do scoring. A higher score means this is more similar to the question, lower score, less similar. The general issue is that embedding models, you could kind of imagine is covering the entire, universe of knowledge, right? But if you're working in an enterprise, your domain is probably fairly small. And so when the embedding model tends to do similarity search, your domain is probably going to be buried within a bigger domain, which itself might be in a bigger domain. And it has a hard time distinguishing what's unique to you because in its mind, everything in finance looks similar. Even if you're just asking questions about checking accounts or savings accounts or mortgages, it considers those all one and the same, right? They're all finance. So by properly fine tuning our embedding model, we can essentially create a domain specific embedding model, which is much better able to distinguish between relevant and irrelevant information. In terms of how it's done, you're going to want to start with a pre-trained embedding model. There's all kinds of them, right? You could take a look at Hugging Face. There's some leaderboards for embedding models, and there's new ones coming out all the time. It's worth testing those, right? Seeing which one naturally does a little bit better for your use case. And once you've done that, we can take those tag chunks that I was just describing a minute ago. We can run those through a foundation model to synthetically generate questions, right? So if I have a chunk that explains deductibles within a healthcare plan, I can send that to the foundation model and it might come back with, here's a list of questions that a user could ask around deductibles that would be answered by this chunk. Once you have, a whole bunch of those pairs, then you can use that metadata in classification to further filter out exactly what you're looking for, right? Depending on what the problem is. Use that data set, fine tune your embedding model. A couple little, visuals on approaching this. I won't spend much time here, but this is what I was getting at earlier, right? The pre-trained model has, things grouped together, all finances together, right? All health is together. If we were to create a fine-tuned model in the finance space, this would allow us to separate, savings information from pre-tax investments from, other types of investments. And then I like this visual as well, because typically when you're building, these RAG pipelines in an IA agent, you're probably going to want to specify a threshold for your relevance. And so if I kind of started out of the box and I decided that 0.75 would be my threshold, on the left, you would see that, well, a majority of the chunks returned are relevant, which is good. And then there's a whole lot of not relevant chunks that are returned, right? There's too much overlap and it becomes difficult to separate them. By fine tuning the model on the right, you now see a very clear separation, right? If I set my threshold at 0.75, I'm pretty much guaranteed to get all relevant information and almost zero, in some cases, zero irrelevant information. That is what's going to be boosting the accuracy of the overall RAG pipeline, in retrieval in particular. As I mentioned before, I'm not going to touch on these two topics other than to kind of give them a little blanket statement here, and that yes, fine tuning the LLM is something that we suggest. I was really excited that Sinduro brought up distillation. I think that is going to be an increasingly standard approach to building specialized models. It's almost mind-boggling what can be accomplished by using, say a massive, 400 billion, parameter model, extracting the right reasoning capabilities and knowledge from it, and then using it to train, an 8B model, maybe a, 2024B model. A fraction of the cost, but does exactly the same job, if not better, because it's focused. But I would need a whole lot more time to dig into that one. And then, yes, re-ranker models are um, similar to embedding models in that there's kind of an element of scoring there. They just take a different approach. So the embedding model, of course, is working on similarities across those embeddings, whereas re-ranking models actually look at the language specifically. The challenge is that traditionally re-ranking models are a little bit slower, right? It's not efficient to put 1,000 chunks into a re-ranker and ask them to prioritize it. It is hyper efficient to do that with an embedding model. So that's kind of why it's our go-to. But being a little bit slower, we could push maybe 5 chunks into the re-rank model to sort them. So there can be some value there. It's kind of hit or miss. And then finally, evaluation. I'm almost finished here. I'm kind of keeping an eye on the clock, so I'll make sure we get that demo and Q&A. And evaluation is a critical part of all of this from the very beginning, as I hinted at. And I'm going to focus just a little bit here on LM as a judge, although that is certainly not the only approach, right? We support lots of different types of evaluators within Snorkel. But certainly I think this is emerging as kind of a standard and more common one, is you can get started with out-of-the-box evaluators, things like chunk relevance, chunk adherence. They're going to kind of provide you some direction, but then you're going to want to go above and beyond that and start creating your own evaluators, because at the end of the day, whether or not an AI response is acceptable to a business has to be defined by the business, right? Nobody else but you can tell you if this is a good response or not. So kind of figure out what your criteria and requirements are, and encode those within, an LLM as a judge. And then also try to categorize your data set. 9 times out of 10, you're probably not concerned about the accuracy of every single prompt or request, but there probably is a category of tasks or questions which are very important, and you'll want to keep an eye on. So that's kind of a critical capability. And then the other 2 pieces are prompt engineering and iterative benchmarks. And I'm going to skip this a little bit now because of time, but you'll have these slides. But ensuring that the tools that you're using have very strong prompt engineering capabilities, and having the benchmarking capabilities, which include human feedback, very effectively, so that you can validate that the evaluators are correct, right? Evaluators are not very good if you don't know or if you can't rely on them. So we need some way to determine that this element judge is actually giving us good responses, right? Or good judgments. And ultimately, we need our SMEs to help us with that. Here's a little screenshot. When it's kind of all put together, you can see how your model or RAG pipeline are improving over time. On the bottom there, you can see how different what we call slices, right, or categories of prompts and tasks. How are they performing, improving, or not improving? And then finally, coming up to the end here, here's just a little example of a Snorkel and AWS architecture, which kind of brings together some of the pieces that Sinduro was talking about with some of the things that I've been mentioning. Ideally, Snorkel Flow is going to be deployed in Amazon VPC. Ours are yours. We'll pull in PDFs and all kinds of other unstructured data from S3 buckets. We will do a lot of what I just talked about in terms of chunking and tagging and synthetic generation and training data development, all that good stuff. And then, as Sinduro mentioned, lots of choices for vector search. We can natively integrate with their APIs to fine-tune embedding models and foundation models. And of course, we can use awesome foundation models like Claude through Bedrock to help us with things like synthetic data generation. So this kind of brings all those pieces together for us. All right, with that said, I'm probably a little bit, about 2 minutes past where I want to be, but we have a demo that we're going to take a look here. I think this is about 15 minutes end to end. We get to see Snorkel Flow in action and some of the things that I've talked about. And then we should have some time for Q&A at the end. And before I play this video, actually I'll kind of bring it up here because I know it takes sometimes a second to kick in. I just remind everyone, please feel free to ask questions. I know I probably went pretty quick through this stuff, but we'll try to get to as many of those as we can. So let me bring up our demo here. And then I'm going to give you a break from my voice and we'll check out Vignesh.
Hi everyone, my name is Vignesh Ramesh and I'm a machine learning solutions engineer here at Snorkel. In today's demo, I'm going to show you how the powerful combination of Snorkel AI, AWS and Anthropic can actually come together to help you build state-of-the-art RAG applications. In order to make a start, I'm going to show you a basic RAG architecture. In a basic RAG off-the-shelf architecture, you start in the ingestion phase where you take your unstructured documents, chunk them, and convert them into vectors. During the inference stage, you take the user's query and do similarity search within your vector database and retrieve some chunks which are then put in the prompt, and the model does some kind of in-context learning to give you a final response. Now, the problem with this off-the-shelf, out-of-the-box architecture is it often fails. It fails for a number of different reasons, but perhaps the most important ones are domain specificity. Different enterprises work in very different domains, and consequently using open source embedding models don't always fit their use cases. This results in incorrect retrievals that are driven by low semantic differentiation between their documents with this open source embedding models. Inability to differentiate acronyms is another very commonly observed problem where the embedding model is unable to make the similarity of the differentiation between the acronym and the full abbreviation. We also tend to see problems due to the underlying LLM itself, positivity bias being something that we observe very commonly, where the LLM tends to answer yes to most questions when the answer is in fact no. So the yes-no bias or the positivity bias is very commonly observed. How we fix these systems totally depends on where it fails. It could be embedding fine-tuning that's actually required, or the model fine-tuning, or optimizing the ingestion pipeline. This is all down to how the system fails, and consequently, then you make the decision of how to actually fix it. Snorkel AI plays in these 4 areas. We can help you do data development to fine-tune your models, fine-tune your embedding models, or do prompt development, or even optimize your ingestion pipeline. Now, the demo today is going to be circled around Finance Bench, which is an open source data set of this format. You've got questions about the different companies and information that comes from 10K or annual reports. They've got 150 questions where human annotators have actually manually labeled the answers. They build an off-the-shelf RAG solution and test it against open source as well as proprietary models. And what they find is that most off-the-shelf RAG solutions tend not to work to production accuracy. Now, here is one example from the Finance Bench dataset on a RAG system that we built. Here's the question, here's the response, and these are the 2 different contexts. Most people tend to see only one thing, which is the response is incorrect, and they've got some kind of metric to measure that and say, my system is 50% accurate. But that doesn't tell us much. This particular system fails due to 7 different reasons, as you can see here. So how we optimize this system is totally dependent on where it actually fails. Now, here's a reference architecture that we typically tend to use to fix these systems. We start with the unstructured document still, but we enhance the content extraction pipeline using a chunk quality grading machine learning model, which is developed within the platform uniquely for your needs. What this quality grading model is capable of doing is going through these different chunks and labeling them as irrelevant or incomplete or acceptable, so we can do post-processing operations on these chunks. Once you've done basic chunking, it's important to enrich your content, and that could be in the form of metadata, which are tagged as additional variables, or it could be in the form of relationships between the different chunks and tables, or paragraphs and tables as a knowledge graph. You also can do dynamic chunking, which results in very high quality chunks. Once done, You will need to fine tune an embedding model, and that's an exercise in data development. You need to curate these different prompts and different chunk pairs, which is done within the platform so you can fine tune the embedding model. During inference stage, it is important to have a routing layer, because today you may have only one vector store, tomorrow you may have 5 different vector store, or tomorrow you have agentic systems that perform multiple different actions. If there's only one vector store, then it goes through the similar retrieval process, but perhaps you may want to consider using a re-ranker if your domain is quite broad. Again, another exercise in data development which can be done within the platform. Finally, we do prompt development, prompt engineering, do inference, and then evaluate these whole systems from within the platform. So that's an end-to-end reference architecture that we typically tend to take ideas from in order to improve these systems. With that said, let's jump into the demo. Your data can live in S3. So in this particular case, my data lives in S3 as a number of different PDF files of different companies and their annual reports. I build an off-the-shelf RAG solution outside the platform, and I import the data into it. What you're seeing here in Snorkel Flow is the instruction or the question, and then the response that this off-the-shelf solution is actually generated. And then you've got 2 context pairs. So this is 1 and this is 2. One of the first things that I noticed when I built this system is that the retrieval often tends to get the document wrong. So for instance, in this case, the question is specific to AMD for the year FY 2022. The first retrieval is correct, but the second retrieval is from a completely different company. So this is from Intel. So obviously this is not a very useful context. Another example, so this question is from Amcor for the year 2023, but the first retrieval is from Amcor for the year 2022. So what I noticed was that the retrieval system gets the name of the company wrong in some cases when doing retrieval, or the financial year wrong in other cases. Bear in mind, I've typed out the name of the file itself here. So when you download it from SEC's website, this is not how it's going to look like. So what I do is I create these 3 custom label schemas for my annotators, for my experts to come and give me some metrics, some annotations to do. They help me annotate this in 3 different dimensions. The first is overall acceptance of the response itself. The second one and the third one specifically around retrieval. The second one focused on company. The third one focused on whether the financial year referred to is correct or not. So they have a workflow within the platform where they come in and accept or reject these responses based on these 3 different criteria. What that helps me do is evaluate the system overall. So what I'm seeing here now is the results of that SME evaluation, SME annotation. This tells me that my system is 14% accurate, which is not very good. And this is being driven by 2 primary reasons. The first one is that the company referred to is correct only about 73.5% of the times, and the financial year referred to is correct only about 36.7% of the times. So there's a massive opportunity for me to fix these 2 and consequently achieve a higher accuracy in the overall percentage. Now, how do I do that? Fairly simple. What I do is I import all the different PDF files, the 10K reports into the system, into the platform. And once again, I request my SMEs to annotate a handful of data points, right? So in this case, this is an example of a financial year. So I request my SMEs to annotate it as FY, and this is an example of a company. So they come and annotate it. Once they do that, and we don't need very many of their annotations, we can use a programmatic data development approach in order to build a model which is able to predict the name of the company as well as the financial year very reliably. How do we do that? 3-step process. Step 1, we build labeling functions. Step 2, we train and develop the model. Step 3 is we analyze the performance of the model, and if you're happy with it, then we export it. To train this model, we need lots and lots of label data. And how do we get that label data? Through labeling functions. To give you an example of a labeling function, what I do is I create a keyword-based labeling function, and I'm specifically looking for the different spans. These are the different spans. And if the span contains the words period ended, then I'm going to label that automatically as a financial year. I know this because I've seen so many of these documents, and I know that the financial year is typically hidden in the same span as where this period ended. What my labeling function does is it looks at every single span, labels all the data automatically, and comes back and tells me how precise this particular labeling function is. This is done using the validation set. The SMEs have already annotated some of this data. So it goes and checks against that ground truth data and tells me how precise it actually is. Another way to actually label some of this data is using prompts. So Snorkel's integration with SageMaker allows us to query some of our models that are actually running in their endpoints. So in this case, I might say, what is the name of the company reference in this filing. And this automatically queries all of the text within this document into our model running in SageMaker, and it comes back and provides me with different labels. We can also use embedding models, so the different spans are clustered in using a spacey embedding model in this particular case. And I look for very homogeneous clusters. So, for instance, this particular cluster has 27 documents. 14 of them have been labeled as financial year by my SMEs. So there's a good chance that the rest of the documents are also financial year, so I can save that as a cluster. Those are labeling functions, and we go through the process of creating these different labeling functions. And what this does is it generates labels very quickly for our dataset. So in this case, 9 labeling functions have generated 974 different labels. Once we're through with that, we can train a model. A number of different training architectures are already available. It could be a simple gradient boost, or it could be more advanced transformers architecture. You can train these models within the platform. And once done, you can analyze how this model is actually performing. This is a clarity matrix, and it gives me guides on how to actually iterate through this process. So in this case, my model does really, really well. So I'm happy with this model, and I go away, take it and deploy it in a SageMaker endpoint. Ultimately, what I try to do is actually extract the 2 important variables, which are the names of the company and the financial year, and that's now available. So what I do is I incorporate them within my different chunks. So in addition to the other metadata attributes, I've got these 2 attributes, and consequently, my retriever works better. Now, let's go back and evaluate the system once again. So how does this system compare to the previous system? So I've got an out-of-the-box 4.0, and I've got a metadata enriched system. And you can see the jump in performance by a simple trick, right? So 14% to 47% accuracy. And this is driven by the improvement in company reference to and the financial year reference to going up significantly higher. Now, information extraction is still quite low in terms of the accuracy. I'm still only performing at 57% accuracy. And we can improve this because the information extraction questions they depend on the embedding model. So we can fine tune the embedding model, and hopefully that will improve the performance even more on this particular category. How do we do that? Once again, an exercise in data development. What I do is I bring in all the PDF files that are in my S3 bucket as URLs. So you can generate these URLs on AWS. Once that's available, it goes through a sequence of pre-processing steps where the PDF files are downloaded, they are cleaned, the text gets extracted, and all the other metadata attributes are added. But finally, I have these individual paragraph spans which are extracted from our PDF files. From here on, I can do one or 2 things. I can generate synthetic data. So this is a code-based operator. I use my SageMaker runtime using my own specified domain endpoint. And I ask the model to simply write a question for this paragraph. Now, this is the easiest way to generate data. There's only one problem with this approach, which is that users may not necessarily ask questions in this exact same format. They may have other questions. And that's where we need to programmatically label some question and chunk pairs using Snorkel's data development approach, right? So I have selected, say, a list of about 50 different questions, and these questions are listed here. I programmatically tag the different paragraphs to these specific questions. Very similar approach to before. Once done, we can launch a fine-tuning job, because what happens at the end of it is we merge these 2 different data sources. 1, where we programmatically curate question and answer pairs, and 2, where we synthetically generate this data. And once that's available, we simply launch a fine-tuning job and we run inferencing on SageMaker. There is an excellent tutorial on how to fine-tune embedding models on SageMaker available on GitHub. I highly recommend you to take a look at it. Now, how will we performed after this? So we're going to compare the performance of that model with the embedding fine-tuned model, or we can even take a look at the chart. And what the chart tells me is that the performance has improved even more. These are the 3 different systems that we've looked at, and the embedding fine-tuned model performs the best among them all. Once again, let's compare. So in this case, I'm comparing the out-of-the-box versus the embedding. Sorry, the embedding fine-tuned, and I see performance has gone up overall at 63.3%. Now, if you have a keen eye, you will probably notice that performance is starting to tank for some of these categories. So this one, which is on logical reasoning, has not really improved. And this is because reasoning is not really the job of the embedding model or the retriever. Reasoning is actually the job of the LLM itself. Now, what do we do with that? So one way to do that is to use other models. Consider your context to be golden, and run inference on different kinds of models. What we have realized within Snorkel AI is that Claude 3.5 performs extremely well on reasoning. So that's why we've developed an integrated Bedrock inferences for Claude 3.5. And what you can do is simply change the different prompts. You've got the user prompt as well as the system prompt, holding your question and your context as fixed, and allow the model to actually do inferencing. From here on, you can also sort of see how SMEs have provided feedback in the previous iteration. So in the previous iteration with 4.0, my SME has said that the numerical reasoning was actually accurate. But for this question, for the previous iteration, my SMEs told me that this is actually inaccurate. So I'm very keen to know what they think about this particular generation from Claude 3.5. So all I have to do is just create a new batch of annotations, allow my SMEs to give me feedback once again. So that's that brings us to the end of the demo. I want to leave you with this particular future state architecture. Fine-tuning RAG systems is actually a fairly involved process, and it needs to be done for your own specific domain, for your own specific data, and what you use and how you fix these different systems is totally dependent on where it fails and what data development techniques will actually help you fix these systems. Thank you.
Really great demo. Although I know that we're sitting here at a couple minutes, 1 minute before the top of the hour, but let's see if we can't squeeze in a few questions with the time left. So we'll try to stay here as long as we can. I'm going to kind of go through. I'm going to go through some I saw in the chat. Vignesh, I know you got to these, but I wanted a chance to share them with everyone else too. Maybe one that's particularly relevant. All this talk about enterprise data and PDFs. How do we ensure that the data is safe and protected, right? That it is not accessible by unauthorized users, let alone folks like us at Snorkel. Oh, you know what? I'm going to take that one for Ganesh. I think he might be working on his camera and audio here. But what he was referring to in chat, one is that Snorkel Flow can be deployed anywhere, including on premises or in your Amazon VPC. So it certainly doesn't have to be running on our hardware that we're managing for you. It's an option, but in the most securest case, I would say run in your VPC, right? So that will take care of that one pretty easily. There was one other one. I'm kind of going to combine these two, and I think this happened when I was talking about metadata in chunks, and there was a question around scale and whether that was done manually or not. So there's two considerations here. One is that it is absolutely not done manually. It can be, right? SMEs can certainly come in and add some ground truth. But what I didn't show it in Vignesh did is that we would use label functions for that, or predictive models, right? Classification models and information extraction models. And that's how we achieve the scale. So hopefully I caught you on that one, that no, it definitely was not implying that you would go in and label 1,000 chunks with the right metadata. Certainly we would do that pragmatically, and in some cases even with an LLM to help do it for us. So it absolutely scales there. Welcome back, Vignesh. Sorry, I took that one for you in the moment there.
Thank you. Yeah.
I was just going through some of the ones that were in the chat, and then I was going to switch over to the Q&A just so that everyone else can tag along in case they didn't see that conversation. One of them is, indexing information, pages, PDFs, instead of, calling an API. That probably happened in either one of ours. It could have been Sonora when you were talking about knowledge bases in AWS, or perhaps when I was talking about, the need to kind of pull in that data. So there's probably a question for both of us. Why don't I turn it to you first, Sonora? I know you might have to leave a little bit before Vignesh and I.
Absolutely. So Amazon Bedrock supports a different variety of knowledge-based sources. So you can put all those files, especially we have seen customers like put all the PDF files or CSV files or any kind of unstructured data into the S3 bucket and use that as a data source tied together with the Amazon Bedrock knowledge data source to ingest the data. And also we have something known as Bedrock data automation that we have it's a new feature, so where you'll be able to extract valuable insights from the unstructured data, like if there are any tables or if there are any pictures. So you'll be able to extract some data and convert it into a structured format and store it into the knowledge bases. So definitely advise you to give that a shot.
Yeah, I think that was the same answer for both of us, right? We're both going to make it easy for you. Dump your documents into an S3 bucket, and I'm sure we both have APIs for
Exactly.
those of you that want to get into a notebook and do something a little more advanced. um, let's see here. One simple one. What chunk practice apps do you recommend? So I think I'm going to rephrase this a little bit into kind of what tools or APIs do you use for chunking? I'm going to answer the simple one I know, and then Vignesh, if you want to jump in, Risendura, and add more, please do. Naturally, we're going to recommend our approach to chunking within Snorkel Flow. We think is pretty effective, but I will concede that there's lots of other tools out there. I'm sure LangChain, Llama Index, many others have the ability to parse and chunk documents. The best I can do is say, don't expect to get too far with token-based chunking, right? I don't think you're really going to want to try to get to production with that. Beyond that, I'll turn it over to my guests here to see if you have any additional thoughts on how you would go about chunking.
Yeah, so there's no one correct answer for chunking. To be honest, chunking is the $1,000,000 question for most firms. Obviously, LangChain and Llama Index offer a number of out-of-the-box chunking algorithms. I say algorithm, but chunking functions, which sort of allow you to do both length level or certain breakpoints within your conversation, or semantic chunking, dynamic chunking, right? But I think the answer to that question really is how you do chunking totally depends on the use case. Totally depends on what documents you're actually dealing with. If you have a markdown file format, for instance, then I would look for specific breakpoints that separates the tables out, the surrounding context with tables, and I would look at those points to actually break it out, right? Which is why we talk about a chunk quality grading model, because what this model can uniquely do for us is look at these different chunks and go, this one's incomplete, right? This one's not properly rendered. Because the other thing to remember is the reason we do chunking is so that we can retrieve it later on, right? That's the most important thing. Now, that's what I was taught, right? This is why we do chunking. We want to get it back again, right? In which case, when we go and get it back, we want to make sure that it's semantically complete. It's not incomplete. We want to make sure that when we've done the retrieval, the LLM has enough in context to be able to respond to the user question, right? So that's the end goal. And with that end goal in mind, how would you work backwards, right? And to work backwards is to say, I want my chunk to be complete. I want it to be semantically different compared to the other chunks that are in place. I want it to be rendered really, really well. I don't want it to be a duplicate, right? And those are the things that we need to optimize for, right? And no algorithm, no function is going to offer it out of the box, right? So this is why sort of looking at your different chunks, looking at what some of the undesirable chunks are, and building a model around this is a huge game changer, especially for RAG applications.
Folks, this is why we bring him on, right? Much better than I would have been able to answer it. I have one more here, Sindura. I think this is going to be far more relevant to what you were discussing earlier. Is there a risk of exposing intellectual property, private data, sensitive data, if we're using an LLM model which is not open source? I expect part of that answer kind of depends on where your model is running and how it's deployed. So maybe you could share some thoughts with us on that one.
Right. So with Bedrock, so it's we have, as I mentioned during the presentation, also the way the Bedrock was built is completely with security and privacy in mind, and always the data is in your own AWS account. It doesn't make its way to any other model providers, even though you use that model. We make sure that the copy of the model is within AWS, and your account is always within your AWS account. The data is always within your AWS account. So it's all, and also the data, it's like there's several different ways to protect your own data, right? There's several different mechanisms. So we strongly recommending utilizing all those mechanisms like encryption, and also there's the data back and forth while it's in transit, it's also encrypted. So there's even if you use your own custom models within AWS, within Bedrock, like if you import your own custom models, the copy of the model is always there within AWS, and it's always, the data is ensured that it's within the boundary of your AWS account. So it doesn't ever make its way past that. This is a very common question that we get, and this is the same answer for the question is the data never leaves your AWS account.
Fantastic. All right, I'm going to bring up one more question here. Uh, while I answer this question and present it for everyone, I would still encourage everyone here, feel free to dump in some more. We're not going to be able to get to them all, but we can certainly try to reach out to you offline. So if you have questions, now's your last chance to sneak them in, get them in the queue, and make sure that we get our eyes on it. But this one was about RAG. So certainly on behalf of Snorkel, Vignesh and I were talking about RAG, and Sindura, you were talking about Bedrock and SageMaker in RAG. And kind of the question here was, well, they're both running on AWS. Is there a difference between them? So I just want to start with one little piece and then kind of open it up to you guys. But to add a little clarity, the RAG pipeline itself does not run on Snorkel. So that is certainly something that's going to be running on a variety of AWS services that Sindura mentioned. From my perspective, we're here to help you do the data development that you will use in your RAG pipeline, whether that means the chunks or that means training data for a better embedding model. But we don't run the RAG pipeline. So that's my little caveat, and then I'll turn it over to you two for more.
Absolutely. So, I mean, I've shown multiple options that you can use with Bedrock for your RAG. You can use connect it to your databases. You can connect it to S3 bucket. So these are the different options that you can use, and you can also choose an embedding model. So they're different tie-ups together with Snorkel that we can have in order to make the data more high quality. So it's all about the data, and the data is the main differentiator, as we have spoken about. So it's very important to have, even though you use a specific data store for storing the data, it's very important to have that kind of a high quality data, which Snorkels allows us to create it. And you have seen the demo, which shows some beautiful mechanisms on how you chunk your data. And especially this is extremely valuable, maybe for finance industry, for specific industries where, you should not break apart terminology, right? And all the chunks with the relevant terminology, the data should be within a single chunk as much as possible. So the higher the quality of the data is, and that you store within the RAG data stores, within the vector data stores, the higher quality responses you get. So it's always, I feel the combination of Snorkel with AWS services can definitely make this a possibility, right? Can allow you to get very high accurate responses, and ensure that you meet your specific needs for your specific domain. So that's the specialty of combining both powers together.
That's very true, right? So you've got the ability to spin off a vector database on AWS. You've got the ability to run embedding models or LLMs as an API endpoints, and you've got this ability to run the whole RAG pipeline within AWS. And that's the place to start, because we're not really a pipeline engineering company, right? So we don't provide the pipeline layer. What we would do then is, you would come into Snorkel to develop some of these components to optimize the system. And let's say once you fine tune an embedding model, or you've built this classification model, which you want to use as a routing layer, you serve that model as a SageMaker endpoint, and you incorporate that in your AWS pipeline, right? That's how we work together really, really well. We are not, we are not, and I don't think we have any plans of actually being a pipeline engineering company at all.
Fantastic. All right. So I will part with first, thank you to everyone for attending today. I know we're all very busy, and you just shared an hour and 10 minutes of your time. It's deeply appreciated. Thank you, Sindura. Thank you, Vignesh, for joining me today as well. It was great to get this information. It was great to see a demo. Outside of that, I think we're about to wrap up here. So if anyone has any questions, feel free to drop them in. But those are my thanks for the day, and we'll see you next time.
Thank you very much. Thank you, Sindura,
Thank
for your
you.
time. Thank you, Shane.
Thank you, Vignesh and Shane.
Bye, everyone.
Bye.